I wanted to record a quick problem for you, or a solution, I guess, a uniform distribution. So we have a store receiving a delivery, whatever, at a time that varies uniformly, and the question tells us that we're looking at a uniform distribution, so that's kind of handy. We don't have to think about it too much, so we know what our distribution is that we're dealing with. And they tell us that it varies uniformly between 7 a.m. and 8 a.m. So here's our window time. Sorry for the bad handwriting. It's going to occur between then. Part A, we want to find the probability that the delivery on a given morning will occur between 7:15 and 7:30 a.m. And for this part of the problem, I think common sense, logic are the best way of going about it rather than worrying about memorizing a formula. We've got 60 minutes here, and we want to know the probability that it occurs within these 15 minutes. So the probability in part A is just 1 in 4, because if you do want to think about it as a formula, the length of that line segment is a quarter of the length of the whole line. But anyway, that is part A. Expected time and variance for part B. I never bothered to remember the formula. Well, the expected time is just the middle. It's 7:30 a.m. and let me just say a couple more words about that instead of just telling you. But remember, in any probability distribution, like in the normal distribution, say, or whatever you have, mu, or the mean, or the expected value, is the point at which half the probability distribution falls on the left-hand side of the line, and 50% falls on the right-hand side. So if you think of this delivery situation as a probability distribution, the uniform distribution is just a rectangle. So we want the point that's halfway in the middle of that rectangle, which is just 7:30 a.m. So that's what the expected time, or mean, is. The variance, however, there is a formula. Recommend that you memorize it. I'm sure there are plenty of things written on why this is exactly the way it is, but let's just plug and play, shall we? A and B are the two ends of our rectangle, so let's think of them as, let's set 7 a.m. to be 0 minutes and B to be 60 minutes, and let's think of this as a block of 60 minutes. So when we calculate the standard deviation of this delivery, it's going to be 60 minus 0, so 60 squared, 3600 divided by 12, and then take the square root of all that. I did that already, so I know that it's 17.32. So one standard deviation to each side of this this line at 7:30 a.m. is going to be 17.32 minutes. So it's a little bit past the quarter of the hour. So the variance, anyway, that's all we had to do, is 17.32 minutes. I suppose if you wanted to get fancy, you could say, well, 0.3 of a minute is a third of a minute. 0.32 is a third of a minute, which is 20 seconds. You could say 17 minutes and 20 seconds. Your prof might appreciate that precision, or they may not. So anyway, that's part B, 7:30 a.m. and 17.32 minutes. This text would be better for that. And C, the probability that the time of delivery will be within one standard deviation of the expected time. So here we're looking at probability again, and we want the probability that our delivery comes between this time that we define to be 17.32 minutes below 7:30 a.m. or 17.32 minutes above 7:30 a.m. Either way, let's just take that 17.32, multiply it by 2, because we want standard deviation on either side, so 34.64 minutes. And then to get the probability, throw that puppy over 60, which is what? 57.7%. So that's our probability for part C. A little bit more than half of the time will be within the standard deviation. That's it for that problem.